This is Jeff Horn, and in this EconCast, we're going to learn how to calculate GDP, the GDP deflator, and the GDP growth index. First, let's take a look at one of the problems that was giving my students difficulties in their homework assignment. In this problem, we have an economy that produces two goods, and we call this economy Twoland. The two goods they produce are oranges and computer software. And we have 2 years we're looking at, 2009 and 2010. And in 2009 they produced 100 oranges at a price of $5 per orange and 2 computer software at a price of $20 each. This question asks us for the real GDP for several years using different base years. It also asks us for the GDP growth rate and the chain-weighted GDP growth rate. Now it's important to remember when you're asked to calculate the chain-weighted growth rate or the chain-weighted price deflator that you pay attention to whether the question is asking for the arithmetic average or the geometric average. There are two different ways to calculate that. And finally, the question asks for the chain-weighted real GDP for 2010. Now this is going to differ from the real GDP that we calculate for 2010 because here we're using the chain weight instead of the fixed weight, which is how we would calculate these particular numbers for 2010. Okay, so first what we need to do is open up an Excel spreadsheet so that we can track what we're doing and so that I can show you the formulas I use to calculate these various things. So I have copied over the data from the economy of Twoland, 2009-2010 production data, that's our quantity, and price data for each of our commodities. Expenditures here means price times quantity for the economy. So you can think of this as all the money that is spent in this economy. So we can use 2009 quantity and 2009 prices, and we can use 2009 quantity, 2010 prices. We can use 2010 quantities, 2009 prices, and 2010 quantity and 2010 prices. So those are the 4 different combinations we have, and I have them listed here. The 2009 expenditures and 2009 prices is represented by this formula. We take the quantity in 2009 for oranges and multiply that by the price in 2009 for oranges, and add to that the quantity and price of software in 2009. And this gives us our total expenditures for that year, since this is only a two-good economy. Similarly, when we look at 2009 expenditures instead using 2010 prices, what we get is we get these 2009 quantities, but now we're using the 2010 prices to calculate the total expenditures. We do something similar for 2010 expenditures and 2009 prices. And lastly, we have 2010 expenditures and 2010 prices. So what I wanted to point out with this section of the table here is that our 2009 expenditures and 2009 prices is by definition the nominal GDP for 2009. That's just the current spending in current dollars. So again, 2009 expenditures and 2009 prices is nominal GDP. Since we're using, for some parts of this question, 2009 as the base year, this is also the real GDP in 2009 with a 2009 base year. You'll notice that when we do 2010 expenditures in 2009 prices, that gives us the real GDP in 2010 using the base year of 2009 prices. And so we just copy our expenditures over here to note that that's the real GDP for 2010 in 2009 prices. Likewise, 2010 expenditures and 2010 prices, that's current year expenditures in current prices, is defined as the nominal GDP for 2010, which also happens to be the real GDP for 2010 when we use 2010 as the base year. Now we have enough information to answer the first several questions. Real GDP for 2009 using 2009 as the base year is simply our real GDP with 2009 in the base year for our 2009 expenditures. That is not using the 2010 prices. Again, that's using 2009, so it's simply 540. Real GDP for 2009 using 2010 as the base year will be 632. Here is our 2010 base year, and our 2009 expenditures using that base year price is going to be 632. And just as a reminder, that is, again, our 2009 production, but instead of using the 2009 prices, we're going to use the 2010 prices. Again, that's how we get real GDP using 2010 as a base year. Real GDP for 2010 using 2009 as the base year means we're going to use the 2010 production and the 2009 prices. So with 2009 as our base year, our 2010 real GDP is 600. And finally, real GDP for 2010 using 2010 as the base year is, again, 696. So here, if either this first question or the fourth question had asked us for nominal GDP, we would have gotten the same answer. Now we have to figure out what our GDP growth rate is using 2009 as the base year. And what we're going to want to do here in order to calculate growth rates is to use our numbers that we have calculated. Now we have to understand what an index is. We also have to understand what growth means in this case. So let's tackle that last question first. What we want is a rate of increase from one year to the next of real GDP. As a reminder, when we want to calculate a percentage increase of something, we're going to have two numbers. And the first thing we're going to want to do is take the difference between those numbers and then make it a proportional difference by dividing by the first number. So suppose we have two numbers, 3 and 5, and we want to go from 3 to 5 and answer the question, what is the percentage increase? Well, the way we'll do that is by taking 5, which is our second number, the number we arrive at. We'll take away from that 3, and that's our difference. Now we have to make it proportional to get a percentage increase, so we're going to take that difference and divide it by the original number, which was 3. And that's going to give us a proportional increase of 2 over 3, or 2/3. Now I happen to know that that equals, in decimal notation, 0.66 repeating, or 66.6%. So now we can talk about what an index is. So we have 66% increase from 3 to 5. And you'll notice that a lot of our index numbers for GDP look something like this. They'll look like 166. And in class we did things like multiply the base number by 1.66. Right? And what does that do? Well, if we multiply the base number, the beginning number, 3, by 1.66, what we should get out of it is 5. Okay, so what I'm going to do in order to show that is we're going to take 3 and we're going to multiply it by something over 3. And the question is, what is 1.66 as an improper fraction, or a fraction that is not mixed? So we have everything in the numerator. So it's got to be above 3 in the numerator. And we have to take care of this 6 in some way. So we're going to take, we know that 2/3 is 66%. So we're going to take 2 and we have to add to it something. Well, 3 over 3 is 1, right? So we're going to have this 6 is 2/3 plus 1. So we're going to add 2/3 to 3/3. And all I've done here in this step is just skip combining fractions with common denominators. So what we're going to get is we're going to get 3 times 5 over 3. Now I know that our 3's cancel, so we're going to get 5 out of it. And so we've checked our work to show that indeed when we take 1.66 and multiply our base number by it, we end up with our second number, 5. So adding 1 to our percentage increase of 66% makes it easy to work with the number. But for conventional reasons, we actually multiply this by 100 in order to get an index of 166. Now, in our base years, our index always equals 100. So whenever you see an index like 166, what you should be thinking in your head is 166 minus 100 equals 66. And that is in fact our percentage increase, 66%. So this is just a really convenient way of storing the data that there is a 66% increase between the base year and our next year, or in this case, we're not really talking about years, we're talking about numbers. There's a 66% increase from our first number to our second number. So now what we need to do is we need to apply this concept back in our problem for calculating growth rates. So our base year growth index is simply going to be our expenditures in 2010 in 2009 prices over our expenditures in 2009 in 2009 prices. This is our real GDP in 2010 divided by our real GDP in 2009. And we have 2009 as the base year. So remember, we're really looking at fixed prices. We're picking one year to use our prices from, and then we're using the quantities from two different years to calculate our real GDP. If instead of using 2009 as our base year, we had instead used 2010 as our base year, see we have 2010 prices here and here, then we would be dividing 696 divided by 632, which is our real GDP from both of those. So we see that depending on which base year we pick, we're going to arrive at different estimates of the growth rate. Neither one of them is wrong. They both contain valuable information, but depending on which base year we pick, we're going to arrive at different estimates. So we arrive at these numbers using what's called the fixed weight procedure. If instead we use a chained weight procedure, we'll include information from both of these estimates in calculating what we're going to call our real or best estimate of the growth rate. So if we use an arithmetic mean, which is the mean that you're used to from grade school, we're going to take both of our growth rates, add them together, and then divide by the number of growth rates we have. In this case, we have two growth rates, using the base year of 2009 and using the base year of 2010. So we add those together and we create a simple average, which we see here. If instead this question had asked, instead of the arithmetic average, it asked for the geometric average, it's a similar procedure, except this time we're going to take those two numbers, and instead of adding them and dividing by 2, instead we're going to multiply them together and then take the square root of the product. If we had instead had 3 growth index calculations to use, we would have multiplied all 3 of them together and then taken the cube root, and so on and so forth. But in this case, it's really easy in Excel to take the square root of a product of 2 numbers, so we just throw it in Excel and it gives us our geometric average. Using the fixed weight estimates, we arrive at the chained weight growth rate. You'll notice that these two numbers aren't that different, and for a lot of these examples that's going to be true. Now we look here at our GDP growth rate using 2009 as our base year. We can get that from the cell here. It's a 111, so recall that an index of 166 means a 66% increase. Likewise, our growth rate of 111.11 indicates a growth rate of 11.11%, which we have here. If we use 2010 as the base year, instead we get 10.126 or 10.12 or 13% growth rate, depending on whether or not you rounded correctly. In this case, I did not. Here for our chain-weighted GDP growth rate, we just refer to the arithmetic mean, since that's what the question is asking for. So that's a 10.62% increase in GDP from 2009 to 2010. Now the next question is asking what the chain-weighted real GDP for 2010 is. And the way we're going to get that is we just simply take our 2009 real GDP, which was 540. You can see from our cell B8 up here, the current/real GDP in 2009 was 540. And we're going to multiply that by the chain weight increase. So we're just going to take 1.1062, okay, and we're going to arrive at 597.34. And if we put that in, we'll get the right answer. Okay, now if instead of the quiz you were looking at the homework problem, it might have been asking you for the price index instead of the growth index. So for our price index, we do something a little different. Here we're interested in looking at what happens when we fix quantities and observe differences in prices. So again, we're looking at differences in prices. That's going to give us our price index. So instead of fixing prices as we did with the growth index, that focused on how quantity changed from year to year. Now we're going to fix quantities to look at how price changes from year to year. So what we're going to do to calculate that is to fix our quantities first in 2009. That's our 2009 base year. And we're going to look at the different prices, 2009 prices or 2010 prices. So we see here that with 2009 as our base year, what we're going to do is take the nominal GDP in the later year and divide it by the nominal GDP in the previous year. So as we were interested in real GDP when we're looking at growth index, here we're interested in nominal GDP. So again, we're going to take the nominal GDP in our later year and divide it by the nominal GDP in our first year. When we multiply that ratio by 100, we'll get a price index. And it looks like it's a 17% increase in prices, give or take. Now, why is it I can just take the nominal GDP of the new year and divide it by the nominal GDP of the old year to get this price increase? This time, instead of using numbers, I'm going to use symbols. So we have an old number x and a new number y. And just like before, we're going to look at a percentage increase as we move from x to y. So the way we calculated that before is y minus x over x. This is really a simple difference between fractions with a common denominator. So that can be expanded out into y over x minus x over x. These two expressions are equal. And we know that x over x reduces to 1. And so this is actually y over x minus 1. Don't worry too much about this minus 1 over here. I just want to draw your attention to the fact that the bulk of the interesting data here comes when we take the new number and put it over the old number. So in essence, all we need to do in order to generate an index, which again is a number with 3 digits if there's an increase, is use our old and our new numbers. So that's what we've done here. We have our new nominal GDP over our old nominal GDP. We just multiply that by 100 to get an index number. If instead we'd use 2010 as the base year, it's a similar calculation, but now we use 2010 expenditures. Remember, we're fixing the quantities, so we're going to allow price to change. So we just take the nominal GDP in 2010 prices over the nominal GDP in 2009 prices, and we get an index of 116. So that indicates that we have a 16% increase in prices from 2009 to 2010. Again, there are 2 ways to calculate our chained weight. We can use the arithmetic mean or the geometric mean. And remember to pay attention to which one the question is asking for. Now let's apply some of what we've learned to a different question. This question comes from Case, Fair, and Oster's Principles of Economics, 10th edition, Chapter 21, question 18 at the end of the chapter. Now, if you're looking at the book question, we're going to have 8 quarters to inspect, 8 quarterly GDP numbers. But I grabbed this screenshot from my econ lab. And in my econ lab, they only ask you to fill out this information for 5 quarters. So they only give you 5 quarters and expect you to fill out 4. So I've highlighted those particular quarters in my Excel spreadsheet. In this question, you're expected to be able to calculate the GDP deflator and the percent increase in the price level. What the percentage increase in price level is the difference between the GDP deflator in 1 year from the previous year. So this isn't exactly correct. Here we've got some rounding mistakes, but in the Excel spreadsheet we have the exact numbers. Now I've already formatted my 2 columns to display as a decimal number with 2 decimal places. So we can see that our numbers line up pretty well for the GDP deflator column, but that the percentage increase in the price level isn't exactly right. And this is due to the fact that Excel keeps more digits after the decimal place than what we have displayed, and in fact, more than are even needed to correctly answer this problem. So let's not worry too much about the fact that these numbers are different than these numbers. Instead, I want to draw your attention to how we calculate this. So just like previously, we're interested in the percentage increase between one number and another number. This time we're looking at the percentage increase between real GDP and nominal GDP. Any difference between real GDP and nominal GDP is attributable to a change in prices. So that's how we're going to calculate our GDP deflator. So what we're going to do is we're going to take our nominal GDP and we're going to divide it by the real GDP and multiply that by 100 to get our index of the GDP deflator. So the way we read this is that there's a 9.69% increase between real GDP and nominal GDP, or it's not really an increase in the sense of moving from year to year. It might be helpful to think of this as a 9.69% proportional difference between real GDP and nominal GDP. We do the same thing for the next number. We take 2009 quarter 2 and divide our nominal GDP by our real GDP, multiply by 100 and get an index there. Now these two indexes happen to be the same, so our percentage increase in the price level between quarter 1 and quarter 2 is going to be 0. Now this brings up an important point. When we don't have a previous year to subtract from, as in 2008 quarter 4 in this question, we can't have a percentage increase in the price level. We need to have this quarter's GDP deflator and the previous quarter's GDP deflator, which is missing in this case. So the only percent increase in price level that we can fill in are for these 4 quarters here. This concludes this EconCast. In this EconCast, we learned how to calculate real and nominal GDP, a GDP deflator, and a GDP growth index. If you have any questions, please feel free to leave a comment or to email me. Thanks for watching.